Hi Connor, welcome to SnapMath. Thank you for sending in your geometry question tonight. So we're trying to prove this answer right here. Prove that BI is a bisector of TP. And we're given these givens. So we're going to put those first. TRAP is isosceles trapezoid. And that's given. And 2 and 3 are going to be the same. So 2 is that TR is congruent to PA, and 3 is BI is already a perpendicular bisector of RA. So those are both given as well. And then from here, what we're going to do is we're going to say that this angle R and angle A are congruent. And the reason why we can say that is that base angles in isosceles trapezoid are congruent. And now what we want to do is, to prove this, we have to prove that it's a perpendicular bisector, meaning that TI is congruent to IP as well as its right angles. First, we're going to try to prove that, that they're congruent. We're actually going to try to prove them at the same time. What we're going to do is we're going to prove these triangles congruent first, and we can do that right now by side angle side right here. And we can prove that these two triangles are congruent. So triangle TRB is congruent to triangle PBA. And that was by side angle side. Next, we're going to say that TB and BP are congruent. And that's by congruent parts of congruent triangles are congruent, CPCTC. So now, what we want to do is, I'm actually going to prove that this is perpendicular right here. But the first thing we need to do is we need to say that RA is parallel to, what is it? TP. It's parallel to TP. These two things are parallel. And that's just the definition of a trapezoid. All right? So from there, we can actually say, because BA is perpendicular, that, or angle ABT is right, that is the definition of being perpendicular. So now the measure of that is 90 degrees. So, and then we know that that's the definition of right. Now we know that angle ABT is congruent to, this is going to be B I'm sorry, this is I, angle ABI. So angle ABI is congruent to BIT. And that's because of alternate interior angles. AIA. And that's from, so this angle is congruent to this angle because they're parallel cut by a transversal. So that means all the way back to, we can go from there that it's perpendicular. So we'll say that BI is perpendicular to TP, right? And we're skipping a few steps, but it's basically the reverse of what we just did right here. And we also know that it's 90 degrees. Both of these are 90 degrees. So that means the triangles are right triangles. So we can actually prove that those two triangles are congruent because we know that BI is congruent to itself due to the reflexive property. And then finally, triangle, was it TIB is congruent to triangle PIB. And this is because of one of our right triangle theorems. It's H hypotenuse leg. And then we know that 14, we know that TI is congruent to IB, or sorry, IP, because of CPT or CPCTC again. And then finally we can prove it because we know that they're congruent and that they're perpendicular. So we know that BI is a perpendicular bisector of, what was it, PT. And that's just definition of perpendicular bisector. I know that was a long one, but that's the way you do it. All right, Connor, thank you for sending it in, and we look forward to answering more of your questions in the future. Have a good night.